Hello everybody, so today we're going to be doing the testing of our inputs on a Link Engine Management ECU. So let's get into it. Right, so as discussed, this is a video to help you guys test the inputs on your Link Engine Management ECU. Today we're going to be using a G4X ECU, but the G4 Plus software is incredibly similar, so a lot of what I say is obviously going to cross-reference over to that as well. Okay, so in this case we're using a Link G4X Extreme. We've got a 1UZ VVTi. This what this harness is set up for, and so what we're going to end up doing is obviously we're going to go through all the inputs that are allocated to this particular harness, and then we're going to start testing all of those. Now, I have done a video on how to set up all your inputs, so again, I do recommend watching that before you watch this, otherwise it's going to be a little bit confusing starting at one end over the other. Okay, so what we're going to do today is we're going to go through each individual input. I'm going to show you how I test it, but as with anything, there's many ways to skin a cat. I'm not saying that this is the only way to do it, but obviously this is the way that I do it, and you guys can feel free to add in if you have any other more appropriate or you feel more appropriate ways. All right, so as with the video where we're testing the outputs, normally what I do is I just start from the top and I work my way down. Most of your inputs are going to be under the heading digital inputs over there. And if we come down here, we've got analog inputs over there. So those are going to be the majority of your inputs, and that's what we're going to be looking at today. Okay. Importantly, I am in the configuration tab, and the reason that is because it gives you this really lovely screen down at the bottom here as standard, and it also gives you the status of all your auxiliary outputs. So when you're testing your outputs, you use that. Your digital inputs are over here, and your analog inputs are over there. So we can see all the data that we need to see to carry out this particular testing. Okay, what I normally do is, first of all, I'm going to test and make sure that they actually are connected to the correct thing. So in other words, that the wiring is correct. And then what you can do is you can actuate on the sensor in some shape or form, depending on the sensor, to see if you can get those changing values on the runtime value list here, so that you can see that they are actually working as well, and you're not just getting, you know, completely incorrect numbers. Now, in terms of calibration and so on, that obviously falls under the how to set up your input. So again, that's why I said watch that video before you watch this one. This one is definitely number 2 in that particular setup of videos. But anyway, let's move over to here. So first of all, we want to look at our digital inputs. So you can see they are highlighted there in blue, so digital inputs. And if you scroll down here, you're going to see that we've actually got our input pins. This is a really nice feature of the G4X. It's not present on the G4 Plus, unfortunately, but obviously you can just go through exactly what you've added in, but this makes life nice and easy because I can see exactly what I've allocated to what, and when you come to test, you can just go to that relevant area. So you can see here we've got digital input 1 and 2. Those are our cam sensors on the inlet bank, because this is a VVTi engine, so we have the 3 cam sensors. The front one for the actual sort of engine position, that's obviously allocated to the normal cam, and then these 2 here are allocated to the VVTi system, because these are monitoring the inlet cams so that the ECU can actually change the cam timing, and it can keep an eye on exactly what it is doing in relation to that. All right, now in order to test those, obviously you have to crank the engine over. You would then use the built-in oscilloscope, the same one you're going to use to check your crank and your cam sensor signals. Okay, so I'm going to leave that out for now because that is another video that either we have done or we are going to do, and then you'll see those particular setups over there. Right, now in terms of what we're going to do today, in digital input terms, we've only got one that actually works on this particular harness, and that is the start position. Now we do have DI4 allocated to oil pressure switch, but in this case the customer's opted for a Bosch combined oil pressure and temperature sensor. That means that oil pressure switch is not connected to anything, so unfortunately we cannot test it in this particular case. Once we've done the digital inputs, we're going to go through the analog inputs and test those. Okay, digital inputs are really easy to test because they are basically either, in this case, the first 2 are position sensors, so they're variable reluctance sensors in this case, and obviously we'd see that particular waveform on the oscilloscope to know that they are connected and working. Right, the other one, like the start position and the oil pressure switch, they're actually just either a positive or a negative, or a 12 volts or a ground. Okay, so in terms of digital inputs, I'm not going to go into too much detail, but you can either have them going high, so receiving 12 volts, or going low and actually then going to ground. Okay, and again, a lot of that is covered inside this setting up your input, so I'm not going to go into great detail on that for this video. Right, so start position. Obviously in this harness here, we are controlling the starter relay via the ECU. Now the only way we can do that is obviously we need to provide the ECU with a signal to say that the person driving it or whatever has pressed the start button or turned the key to the start position. Okay, so what we're going to do now is we are going to go over to our system over here. We've got our starter wire over here, which is our black with the yellow one, pretty standard there. All I'm going to do is provide it with 12 volts. And what we're going to do is we're going to have a look here where it says DI3 in yellow. And as soon as I touch 12 volts, you'll see that it goes active. And as I let go, it goes inactive. All right. So that's the testing of that particular one. Digital inputs are really super simple like that, because again, most of the time it's just an on or an off. It's either getting 12 volts or it's getting a ground, and you set up which position is active and which position is inactive in that regard. And I do apologize, it started to rain, so you might hear some rain noise in the background. The workshop is insulated, so we do block a lot of that noise out, which is fantastic. Okay. Right, so what we're going to start doing now is we're going to move over to our analog inputs. Now these are the ones that you're a bit more testing on these ones, because obviously you not only have the fact that it's connected to the right thing, but obviously the fact that it actually moves or changes depending on what the sensor is. All right, so again, we've got the exact same setup. I'm just going to close the digital input setup there so we can get over here. We're going to go down to our input pins over there, and what we can see here is we've got analog temp 1 is engine coolant temp, analog temp 2 is IAT, analog temp 3 is engine oil temperature. Now the harness does have built-in facility to have fuel temperature. Customers opted just for a fuel pressure sensor in this particular case. So our analog temp 4 is empty, but it is physically wired to the plug. Then we've got analog voltage 1, which is our TPS main, analog voltage 2 is TPS sub, analog voltage 3 is pedal position main, and analog voltage 4 is pedal position sub. Now in this particular case, I have actually wired up all the drive-by-wire system, even though this customer's harness is having ITBs. I've done it so that we can actually physically test it, and obviously so I can do this video for you guys as well, so we can have a few more things to look at. Next up, we've got analog voltage 5, which is map sensor. We've got analog voltage 6, which is oil pressure, and we've got analog voltage 7, which is fuel pressure. So obviously we've got engine oil temp and oil pressure. It's in a combined Bosch sensor all in one for that particular setup. All right, so what are we going to do now? First thing I'm going to do is I'm actually going to go around and I'm going to unplug these sensors one by one, and what we're looking for is the change of value in there. And also you're going to see it's going to throw an error code as soon as I unplug it, because of the error values that were put in when we set up the inputs originally. Okay, so what I'm going to do now is I'm going to move from there over to there, because this is where we're actually going to see all of our values. So as you can see there, the top one is TPS main, second one is TPS sub, third is APS main, 4 is APS sub, 5 in white is map, 6 in light blue is oil pressure, 7 in orange is fuel pressure, and then going down we've got analog temp 1 ECT or engine coolant temp, analog temp 2 is IAT, analog temp 3 is engine temperature. All right, and importantly what you can see is you can see the voltage values there across here. This is how we're going to determine whether or not they are connected to the correct thing. So as an example, your analog temperature inputs, they have built-in pull-up resistors. So that means that if I disconnect them, they are going to float at 5 volts, which is evident by the analog temp 4, which you can see, which is floating at 4.98 volts. Your other analog inputs 1 to 11 do not have a built-in or standardized pull-up resistor set to them. So therefore, you either have to add one in your harness if you wanted to use something that was only a 2-wire sensor like a coolant temp sensor, or in most of these cases, all of these particular sensors do actually work on a 5 volts sensor ground and a signal system, so therefore we do not need to add a pull-up resistor. Now what I mean by that is if you look at analog voltage 8 to 11, you'll see that they are sitting at 0.02 volts, so they are going to ground because they are disconnected. So this is going to become important. Obviously when I start pulling all of these temperature sensors out, you're going to see they're going to shoot to 4.98 volts. That tells me they're disconnected and they're not connected to anything. And obviously these top ones here are going to then go to 0.02 volts to make sure they're not connected. All right. So first thing we're going to start with is the TPS. Now we can see we've got a value of 0.8 and 2.54. Again, because of drive-by-wire system, you have two sensors, and they go in, with the Toyota's case, they go along with each other to a certain degree. And then obviously that is how the ECU tracks whether the TPS is working exactly as expected to. So in this particular case now, what I'm going to do first of all, I'm going to unplug the TPS sensor. And as soon as I do that, obviously you can see straight away I'm getting an error code there for the check engine light, and you can see she's flashing away there now, or yeah, there she is. Okay, so but most importantly, you can see here that our analog voltage 1 and 2 have now dropped to basically 0.02 volts. Okay, so that is exactly what I wanted to see. I've unplugged the TPS, and the TPS sensors have dropped to 0. So that is perfect. So what I'm going to do now is I am going to plug the TPS back in. All right. And as soon as I do that, you'll see straight away that the TPS one has gone back to 0.8 volts and the TPS sub has gone back to 2.54 volts. Okay. And again, I really hope you guys can see this. I don't know if the GoPro camera is going to record it nicely, but what I'm going to do now then to test it and make sure that we're actually getting some sort of signal is I'm just going to put my fingers in here and I'm going to move the throttle blade. Okay. I've got the drive-by-wire motor set to not run when stalled. So obviously there's not going to be a motor fighting against me when I do this. But as I move it with my finger, hopefully you can see there, the main is now at 3.44 and the sub is now at 4.98. And as I let it go, you can watch them go down like that. Fantastic. Okay, so now that tells me that not only is my TPS wired to the correct thing, but that my signals are correct as well, because you can see my sub actually maxed out before my main, and that is how the Toyota system does work. Okay, so I know that my main and my sub signals are exactly spot on what I'm looking for. Right, next up we've got our analog voltage 3 and 4, and that is going to be our pedal position. So as you can clearly see, I've currently got on APS main 0.79 volts and on APS sub 1.59 volts. And all I'm going to do is I'm going to come across here. I'm going to quickly unplug that. And as soon as I do, you can see straight away that APS main and sub have now dropped to 0.02 volts. Okay, so that tells me that those two signals going to the pedal are absolutely correct. And what I'm going to do now is I'm going to plug this in, or back in. Okay. And as soon as I do, straight away, there it is. APS main and APS sub have gone back to their old values. And what I'm going to do now is I'm going to press the pedal down. And as soon as I do, you're actually going to see those values go up and down, up and down. Okay. Right. So that is exactly as I expected. And again, I'm using the same principle that the main source usually starts lower than the secondary source. So I know that the main and the sub are in the correct order as well. So we're super happy with that. Right, now looking at our map sensor, it is displaying 4 volts at the moment. And as I take a look down here, all I'm going to basically do is just unplug the map sensor. So give me a second. So you can see I've unplugged the map sensor there. And as soon as I do, you can see the map voltage drops to 0.02. So again, that's telling me everything is perfect. I've only unplugged the map, and that has gone down in value. All right. Now then, how do you test this? All I'm basically going to do is I'm just going to pull this pipe off of here. Okay. And then what I'm going to do is basically suck, because a map sensor obviously detects vacuum, because it's an absolute sensor. So remember, a gauge sensor measures from atmosphere up. An absolute sensor actually measures down to a total vacuum, which would be 0, which would mean you're in space. Okay, so you're never going to get to 0. Right, so all I'm going to do, and I'm not going to be able to move it a lot, but I'm going to suck on the pipe, and then you're going to see the 4 volts is going to change. So hopefully you saw that I went down to about 3.5 volts. So again, I'm super happy with that. And I know that the map sensor is reading correctly, and I know it is wired to the correct place. Okay. Next up, we're going to do analog voltage 6, and that's oil pressure. So you can see that is right now at 0.49. Engine oil temp is going to be at the same time because they're the same sensor, and you can see that's 3.33 volts on there. Okay. Now, seeing 0.49 or 0.5 volts is completely normal on a pressure sensor, because most of them work from 0.5 to 4.5. Okay, they do that so you can have the error values on either side of 0.5 of a volt. Okay, but obviously depending on your sensor, this is where you do your calibration. If this is a 150 psi sensor, and basically 0.49 or 0.5 would be atmosphere, and then you would have 4.5 being 150 psi, and it would be a completely linear graph like that, unlike temperature sensors that have a graph that looks more like that. Okay, right, so getting back to that now, all I'm going to basically do is I'm going to unplug the oil pressure and temp sensor. So again, I need both hands for this. Okay, right, so I'm just going to put this down here for a second. And the second I do that, you see oil pressure has now dropped to 0.02 volts. And importantly, engine oil temperature is now sitting at 4.98 volts, the same as analog temp 4. So as I said, these have built-in pull-up resistors, so they basically pull up to 5 volts. So that's where they should sit, between 4.9 and 5 volts. And then obviously, when you actually add the sensor to it, it will pull it down via resistance. All right, okay. So next up, what we're going to do is we're going to plug that back in to make sure that that is working correctly, and those values should return to normal. Okay. And again, straight away there, my oil pressure has turned to 0.49 volts, and my engine oil temperature is at 3.34 volts. Okay. Right. So I'm going to interject here because basically what I would normally do when I'm actually testing a harness is I actually connect my air compressor to the sensors via a rubber tube. Reason I do that is twofold. Number one, I obviously have a dryer with a regulator, so I can regulate exactly what the pressure is coming out there. That helps me to determine that my calibration is correct. So if I have 3 bar on my compressor, my regulator, and I put the air straight into the sensor and it reads 3 bar, then I know that we are accurate in terms of what it's reading. In this case, I'm not going to have the compressor on because it makes a hell of a noise, so I do apologize about that. But if I blow on them, they're not really going to give you any sort of real value, and obviously I can't hold the sensor down there and show you on the screen. I might try and do it with the fuel pressure one because that's much closer, and maybe you can see that slight upping of the voltage when I do blow into it. Okay, so the next step we're going to move to is obviously the fuel pressure there. So again, that is 0.49 volts. And again, all I'm going to do is unplug the sensor. Just unplug that. So there you go, completely unplugged. You'll see fuel pressure has now dropped to 0.02. I'm going to plug it back in again. And as soon as I do, it goes to 0.49. Now this one I am going to try and blow into, so you should see that 0.49 go slightly up. I think I got to a whopping 0.53, but the test is what we're doing, so we're making sure the voltage does go slightly up when I apply a certain amount of pressure to that particular sensor. Again, my preferred method is with a compressed air. Now, obviously, you guys don't always have compressed air, and usually you know exactly what your sensor calibration is, so that should be input. So 99% of the time it's going to be fine. I always like to do a sanity check and just make sure that obviously what we're reading is correct, and I do that via a compressor. Okay. All right, so next up, after fuel pressure, we can move down to the ECT and the IAT, or engine coolant temp and intake air temperature. So again, my ECT is sitting at 3.07 volts. And what I'm going to do is I'm going to come over to the engine over here, and I'm going to unplug my engine coolant temp sensor. Second I do that, ECT goes to 4.98. And obviously it's issuing a fault code. So you can see as I'm unplugging everything, I'm getting large amounts of fault codes popping up here. And that's due to the way we set up the sensors on there. So again, 4.98 volts. We are just going to go and plug that into there. As soon as I do, you'll see the ECT drops to 3.07 volts. Okay, so we know that that is wired correctly, and we know that the sensor is working because it is dropping the voltage via the resistance. Again, if you want to test something like this and you want to test it in the same way that you would with a compressor, can be slightly difficult because the only option you really have is obviously to boil some water. Problem with that is it takes a while for engine coolant temp sensors to actually have that heat sort of build up inside the sensor and become accurate. They're not incredibly fast. And so in that case, you know, you're going to be able to get as well as you possibly can. But yeah, that's pretty much the only way to test that. Worst case scenario, if you have a heat gun that's got a controlled temperature, obviously you can use that as well. So let's say you can set it at like 50 degrees. You can then just hold that heat gun on the sensor. But then again, it is a brass sensor usually, so you can have an extra heat buildup in there. So again, I wouldn't deem that as being incredibly accurate. Usually the hot water method is the best, but again, it also is not exactly super accurate. Okay, right, so that is the ECT. Next on, we're going to move to the IAT. So that is 3.29 volts, as you can see over there. And again, the same procedure. It's going to get super boring now. This is the last one. I'm going to unplug the IAT, and you see that is shot to 4.98 volts. So I know that's been disconnected. I'm going to plug it back in again. Click. And there you go, 3.31 volts. Okay, now with this one, I wonder if my breath, or yeah, the heat of my breath is going to be able to make it go up. So just bear with me a second. I'm just going to try and do it. So we're at 3.29 volts. And you see that has dropped down. This is obviously a fast response one. The element is completely open. So as soon as I breathe on, you see it goes 3.27, 3.28. And it's dropped down to all the way to 3.23. Again, you could probably use, if you had a heat controlled heat gun, just to blow sort of 50-degree heat over that, and you could see exactly what you're seeing on the ECU over there. So that could be a way that you test that. But again, most of the time with these particular sensors, they're so common now. Hopefully there's either a drop down option, especially if you've opted for, you know, all Link sensors on the engine harness. That is one of the benefits of that, is obviously all the calibrations are there and ready to go. All right, I just like to do sanity checks, because as we always know, sometimes you may get a sensor that's faulty, and obviously that can affect the way the engine runs, and especially when it comes to tuning, especially when you start using, you know, tables to change things like fueling or ignition control, for instance, engine coolant and intake air temperature. You kind of want to know that they are very accurate. A lot of the times with the intake air temperature sensor, sometimes it's just useful to have a little thermostat in your workshop. So if you plug it in and what you're seeing on this IAT and what you're seeing on your thermostat in the workshop, if they're within a degree of each other, then clearly you know that you are pretty much in the ballpark figure. And then you can just take a heat gun, heat it up, and then at 50 degrees, see if you see 50 degrees on there. If you do, happy days, then obviously you know you're pretty much accurate on that one over there. All right. Okay, so that is pretty much all the inputs that we have on this particular harness over here. Now, obviously, I've covered testing a temperature input. I've covered testing an analog input in terms of that. I've also covered testing a digital input. So those, for the most part, should be what you guys are going to come across when you do this over there. Now, obviously, when we build harnesses, we go and we test all of these things, including with the compressed air on the pressure sensors, so that we know that everything works exactly as it is supposed to. But obviously, if you are building your own harness and you're doing that, this is a really nice thing to do before you try and start it up, just to make sure that everything is running correctly, that all your sensors are working, and most importantly, accurate. And that's going to then make sure that when it comes time to start, you've obviously got nothing standing in your way. So again, if you follow the procedures that we've done from the beginning right the way to the end, by the time you come to start, you've already assigned your inputs, you've tested your inputs, you've assigned your outputs, you've tested your outputs, you've checked your base timing to make sure it's okay, and you've gone through that procedure. And then when it comes to start, it should be a relatively straightforward affair. Okay, so again, thanks guys for watching. I'm going to cut it off here. We're already at 23 minutes. But what I'm going to do is, anything you guys want to know, please ask down below. I don't know what you don't know. So again, if you guys can give me suggestions on things that you would like to go through in terms of Link Engine Management System, we do have another 2 Link harnesses coming up at the moment. So again, if you get those comments in now, I can more than likely do those videos as soon as those 2 come up. But thanks for watching, guys. Hopefully it's been super helpful. And again, leave a comment down below on anything you think that maybe wasn't helpful or anything else you'd like to go through. But thanks for watching, guys, and we'll see you again soon. Bye-bye.